Welcome all to our first ever SE Aerospace monthly partner spotlight webinar. We're so pleased to have Rick Opedisano and Don Guest from Delta Bravo here to show us how it's done. They're the first ones in the gate here. But for those of you that are new to SE Aerospace or that I haven't met, my name is Steven Asnaborski. As Adrian said, I'm the director of SE Aerospace. We are an industry cluster of public, private, nonprofit, and educational institutions in the state of South Carolina that work to connect, support, and grow the industry within the state. We have three main lines of effort: actionable research, and some of you may have seen our 2020 economic impact study for aerospace and its growth over the past 10 years in the state of South Carolina. If you haven't yet seen it, I'd recommend checking out the SC Biz TV YouTube channel, and you can see the recording there. We also do workforce development programs, mostly by partnering with our educational institutions, K through 12, our technical colleges, and our four-year universities, to make sure that we have a ready workforce to get to work and support our growing aerospace cluster here in the state. And lastly, we support networking events and events like this to bring in speakers to hear about new trends and new things in the industry and make those business connections where we can. So hopefully everybody can grow and be even more competitive than we already are. Before we hand it over to Rick and Don, I'm going to hand it over to my boss, Susie Shannon, the president and CEO of the South Carolina Council on Competitiveness.
Hey, thanks, Stephen. What an outstanding job, too, in laying out the council and what we do and why we do it. So SE Aerospace, as you all know, is a rock star sector in our family of clusters, which also includes SE Logistics and our newest one, SE Tech and Cyber. We do this work for our partners across the industry sectors, but we certainly can't do it without them. So we are pleased to highlight. So Rick and Don, over to you all.
Awesome. Well, thank you very much, guys. Number one, we are honored to be your first go here. Yeah, we're super excited. So let's get this party started. So can everyone see my screen all right? We're good here? Check. All right, yes. Excellent.
We got everyone's on mute.
All right, yeah, yeah, that's true. Yeah, the feedback will be limited. So guys, again, my name is Rick Opedisano. I'm the CEO of Delta Bravo Artificial Intelligence. With me is my colleague Don Guest, who was our Chief Revenue Officer, and Don leads the strategy for communicating with folks like yourself. And so what we're going to cover today is just a little bit. We're going to start off with our perspective on what's happening in the aerospace industry from again, with the customers that we're working with. How are their priorities changing as a result of what's happening here in the new normal? And then we're going to get right into how we're addressing some of those priorities, starting with a very brief and kind of fun primer on what AI is and how it works. Then we're going to get into some very specific use cases that we've worked on in the aerospace industry. And then we're going to dive a little bit deeper into a specific use case with Rolls-Royce that we've executed here in South Carolina. From there, we're going to share a couple of lessons learned and really just kind of open it up, have some discussions with the folks that are on, and try to answer any questions and go from there. So we hope that you guys get a ton of value out of this. We've put a lot of effort into this, and we're gonna have some fun. So Don, let's start off with you. Why don't we talk a little bit about kind of what we're seeing out there from just a general industry perspective?
Yeah, absolutely. Rick, Steve, Susie, thank you all very, very much for this opportunity. We spend quite a bit of time understanding the pressures and opportunities that our clients face in different industry verticals. For example, in aerospace right now, we keep our finger on the pulse very closely with regard to IATA. We do Accenture, Goldman Sachs, and so forth. And what we thought we'd do is just share what we think is some very good graphical representations of what we all are hearing, seeing, experiencing in the market right now. Whether it's just the enormous drop in air traffic or the change in aircraft delivery schedule. And then, of course, what we call the aerospace index, which is really a measure of the economic success outlook of the industry here in North America. And really to put all of this in perspective, I'm not sure if people on the phone are aware that companies such as Spirit AeroSystems has reduced its fuselage and component production for the 737 platform by almost 2/3. And to pull that back into Boeing, who has moved all of its wide-body production to South Carolina, the 787 production has been dialed back to 6 per month. The 777 and X, they've dialed that back to 2 per month. And then they're slow walking the 737 production out to 31 per month over the course of the next 18 months. So there's a lot of pressure for our clients, whether it's EBITDA, CapEx governance, meaning if I'm going to spend a nickel, I want to make sure that I'm spending it on the right thing or the right team. We've got supply chain pressure. OEMs right now are really working closely with their suppliers to understand what the adjustment and delivery schedules mean to them and what is the financial viability of the different participants in their supply chain. And of course, as everyone knows, critical parts remain front and center for everyone. So really the conversations we're having about how can we use machine learning and artificial intelligence to look forwards and backwards across the supply chain. How do we balance critical and non-critical part demand forecast and our inventory levels? And then again, how any nickel that an aerospace company is spending right now really needs to be focused on EBITDA. And so this is what we're seeing, and we've focused our entire presentation on making sure that people understand that machine learning and artificial intelligence has a direct correlation to the economic performance of your companies and the companies with whom we work. So Rick, thank you very much.
Excellent. Okay, so now that you guys have a little bit of a context on kind of the folks that we're working with and what's important to them, what's driving decisions, the next thing I want to do is just kind of get into just a very brief kind of definition of AI and how and where this fits in. So first thing we always like to tell folks is that number one, when they say what is AI, it's not Skynet. All right. When we talk about AI from our perspective, this is a technology-based framework that helps our customers solve problems quickly and more accurately than they can do themselves. And when we think about this is all predicated on the concept of taking massive amounts of data. Okay, so let's kind of think about this, how people learn. All right, so easy question: would you put your hand on the hot stove? No. Well, why not? Right? Because at some level, that there is a bad outcome. Well, how do you know? You may have been given historical context by someone you trust. You may have seen someone do this. You may have heard or read about it. Right? So ultimately, you have built a bulwark of historic data that has told you that there's a bad outcome if you do this. And this is kind of the first tenet of AI, is collecting data on what a good outcome and a bad outcome is in a particular scenario. And, to kind of follow that through, would you drive through a brick wall? Easy question, right? Definitely not. And because again, that there's a bad outcome. However, given your ability to take in historic data, right? That there are alternatives. So if you are speeding towards a brick wall, based on your historic data and understanding of the alternatives, that you can brake, you can turn right, you can turn left. And this is really how AI works fundamentally. It's the idea of taking data, historic data, from a multitude of perspectives and a multitude of sources to understand the probability of an outcome occurring in a given scenario. All right, so if we had AI in this case, it would quickly figure out whether we should brake, turn, left, right, any combination of that. It would figure out which of those combinations offer the highest probability for the most favorable outcome and would give us that recommendation. So again, just a real high level, really kind of a fun way to look at it, right? And so where does this type of a capability make sense? So when we think, where could we use this? Where, in what scenarios do we have a ton of data coming in from all these different sources that we'd love to put together and create some sort of a predictable probability-based outcome? The first area is parts of the business that require forecasting, so better forecasting. This is the idea of saying, hey, maybe I want to forecast unplanned downtime. Maybe I want to forecast inventory movement. Maybe I want to forecast demand. Ultimately, when you take a look at the business, maybe I want to forecast a quality problem, right, and be able to avoid it. When you take a look at parts of the business that require more granular forecasting, those are great targets for an AI application, for a machine learning application. Another area is focusing on parts of the operation that, man, we just can't seem to quite figure out. So we've all seen those quality scenarios where you're going through a process, and whether it's in plant A versus plant B in two different parts of the country that are using the same recipe or the same process, however, we still have some level of variation in the output. We can't seem to figure it out. This is really another area where machine learning and AI stands out. So just to give you guys an idea of what you're looking at, if you look on the screen down there, you'll see a gray shadow. So that is a common application of an anomaly detection algorithm. All right. So what that does is that gray shadow takes all the historic data on how a particular machine or process is performing and says, hey, when this machine or process performs in an ideal manner, that metric is here within the gray shadow. So you see that when that metric is in a good place and things are working the way they should, it stays within the gray shadow, life is good. You also see that when that metric pops out of the gray shadow, that constitutes an anomaly. And that anomaly may be something that is not significant, but it may, over time become something that is. And this is a great way to really get into the details when you bring in a bunch of data sets together and you identify anomalies and how they work, and understand, what is causing this problem that we've had trouble identifying, repeating, and isolating. Right. So there's a couple of ways that we're just in terms of general kind of ideas where AI is used. Let's get into some specifics. Let's talk now about kind of what we're doing with our aerospace customers. So with that being said, all of our aerospace customers at some level are going through the same process, right? So they're saying, hey, how can we take data from all over this operation, whether it's in a plant, whether it's from the supply chain, whether it's from our inventory, our maintenance groups. What we want to do is we want to bring all that data together to help us understand how we can operate more cost effectively, more efficiently. And when we think about the specifics of those wishes, number one thing that we see a lot of that Don kind of referred to earlier, right part in the right place at the right time. So we work with your RollsRoyces, Department of Defense. This is a big deal, right? We all know how many pieces go into this operation. So number one, being able to make sure the right part is in the right place at the right time. Number two, predictive quality. Can we get in front of the cost of poor quality? Can we identify things that are impacting our ability to deliver EBITDA and also limit our ability to pay out warranties, right? So that's another big one there. Number three is scrap reduction. Obviously, there's some folks here that are involved in businesses that have a high cost of making something, right? So if we could limit scrap, that would be great. We'll talk a little bit more about one that we're doing in this area as well. And then number four, predictive maintenance. So this is the whole idea of saying, hey, how can I avoid unplanned downtime? How can I make downtime something that I know is coming, know what's going to cause it, and then plan to remediate in a way that does not impact the business negatively, right? So these are things that we're seeing out there in terms of very specific use cases around how people are using data and focusing on AI. So let's talk a little bit about, when they start getting into it, what happens, right? Are there any red flags here? So what we find is that, again, when you think about this whole concept of bringing in data from multiple sources to identify these problems, predict them, get in front of them, avoid them, people are finding that this is a little bit harder than they thought. And the very first thing that they're finding is when you bring data from all these sources, and guys, this is just a sample of some of the source data platforms that we work with. When they bring this data in, our customers are finding there's pretty much 4 red flags that are really hard. The first one is that, hey man, getting data out of those systems, that's proving a little bit harder than I thought. And that may require a custom developer, the type of skill set that they may not have that skill set in-house, right? And then the second thing is once that data is out, putting it all together and understanding what data is relevant, what data isn't relevant, getting rid of duplicate data, starting to map out standard deviation stuff, outliers. Who's got the data science skills to put all this data together in a way that makes sense and that is statistically has a high degree of statistical integrity, right? Then from there, once we've got that data set all cleaned up from all these different pieces and parts, who's going to use that data set and learn, who's going to create that machine learning model that we're going to use to identify anomalies, to predict outcomes? Who's going to put that together? And then lastly, now that we've got this nice model working, congratulations, who's going to put it into a format and deploy it in a way that our operators can actually use it on a daily basis to achieve value? So those 4 red flags, they're really kind of why we exist. So you think about what Delta Bravo is. We have built a technology platform that streamlines this process, making it happen a lot faster. The big thing for us where we really shine is getting to a clean data set quickly, and also being able to deploy these models in a way that operators can actually use. We're going to show you guys some examples of how we do that today. I think anytime you work with a manufacturer or someone in aerospace, you can talk about these great capabilities, but if you say to them, hey, in order for you to get this capability, you've got to change the way you do things, that's a hard no, right? So what we've focused on is creating a platform that allows us to export this capability, share this capability without having much of an impact on how business is done on an everyday basis. So that's kind of a little bit of an overview of kind of what AI is and kind of how people are getting into it. Let's talk a little bit about some reality. So this is an example of a predictive maintenance scenario that we're working on with a couple of our big customers out there. One of them is a global electric car company. We'll just leave it at that. And on that company's line, our customer has a number of machines. If their machine has any sort of unplanned downtime, they will be fined. Okay, so this is a big deal. This car company's plant is running 24/7. They cannot have any unplanned downtime. And so after a scenario where there was some unplanned downtime and it took about 2 days to get the replacement part in, we were called in to help resolve this scenario with a predictive maintenance application. So what you're seeing, this is a good example of how data can come in from multiple sources. So the first thing you're seeing is over here, we have what's called a digital twin. Okay, this is where we've kind of, I guess you could say, digitally represented the plant floor with the machines that our customer has on it. And you'll see that there's 4 lines. We're looking at machine number 138 on line 3. And what we're doing is we're taking data from the PLC directly from that machine, also from the MES that brings in data from multiple machines. And then we're also, and what we're doing with that data is we've looked down here. You guys remember our anomaly detection stuff down here that we talked about before? We're baselining that machine's performance. And we're saying all these metrics that come off of this machine, if every single one of them acts correctly, they should be in that gray shadow. Well, what about the ones that don't? What we do is we start looking at it and we say, hey, let's put together some of these anomalies. And based on historic data, we can tell what anomalies work together to trigger a scenario of performance degradation or unplanned downtime. And what's really cool about this is that we've combined this machine data and those models for predicting, for these anomaly detections and kind of performance degradation prediction. We've put that together with data from the ERP system, which in this case is SAP, and data from SQL, which is what their maintenance database is housed in. And so what's cool is that when we combine those 3 data sets, not only do we have a good prediction and an understanding of what's contributing to performance problems and downtime, but we can also map out the probability of when that downtime is going to occur, what is going to cause it, and what they need to do to fix it. So this customer is very good about maintaining their maintenance history. So we can turn around and look at all their historic maintenance entries and say, which one of them look like they've got a profile that's similar to what we're predicting here, and what was the ideal troubleshooting path to solve that problem. So this is, again, just a good example of what we can do with predictive maintenance applications, bringing in data from multiple sources, and not just solving the problem of unplanned downtime, but also solving the problem of making sure your operators and your maintenance teams are educated to the best level they can. I mean, that's another big thing that we're seeing with our aerospace customers particularly, is that you've got a group of folks that are thinking about retiring soon. Bringing folks in that can back them up, fill in those gaps has proven to be a challenge. If you can close those gaps by having, with tools like this that tell you very quickly what's going to happen, when is it going to happen, what's going to cause it, and what can I do, that's a big deal, right? So that's one application. Another big one that I mentioned earlier is predictive quality. So this is another great story, another great South Carolina story up here in York County. We're working with a manufacturer that's making over 400 silicone-based products using the same line. So a lot of variation, a lot of configuration-related downtime. And what they wanted to do is they wanted to say, hey, guys, we've got this continuous process that when we start, we just can't just stop it. However, can you help us predict when and where during this process we may encounter a quality problem, and help us understand what we can do. What can we do to change that? So what we were able to do is take a ton of historic data, and we can actually predict when they are going to fall out of spec during this process, show them when and where, and tell them what raw materials to add and where to get back into spec. And so sounds pretty cool, right? This is the interface that we've used to do this. It looks like a calculator. This is the interface that maps very well with their quality process. And you can see over here where in the process we recommend adding a particular raw material. And so this process, just in the first 6 months, reduced waste in that facility by 67%. So this is a big time quality metric and a big time scrap metric. So again, very big deal here in terms of a predictive quality use case. Another one is the right part in the right place at the right time. So this is from a huge tier 1 auto supplier. They've got about 500,000 parts coming across the Atlantic to the US every single day. Those parts have to go someplace, right? Whether that's to a plant, to a wholesaler, to a reseller. And ultimately, their challenge is held inventory, right? Is there any way that we can get this inventory right? Is there any way we can do a better job of tracking where our parts need to be and when, right? So what we've done here is that they had some existing models in place. And so like a lot of folks in our industry, right, you see these guys that have fairly complex Excel spreadsheets that have data around this. The trouble is that they're static models, meaning that they're very complex and they're built to have the same input over and over and over. But what happens if conditions change? What happens if we add a new part, a new supplier, a new requirement? They've got to go through and redo those models, and that takes a long time, and it takes a long time to test and prove them. So what we did is we said, hey, let's start with your model, but then let's also ingest a ton of historic data. Let's also ingest weather data, because in this case, weather has a level of impact on logistics, supply, and demand. Okay, let's bring all this stuff together. Let's start web scraping and look at your competitors to see if they had any specials in particular geographies around the same time that you had an inventory shortage or excess, right? So we started putting together a picture of all these different data sources, and what we ended up with was a model that predicted inventory movement and demand at a level that was a little over 60% more accurate than what they were able to do on their own. How did this translate? Translated to about a $3.5 million savings in held inventory. So we have done a pretty good job of really kind of nailing down this type of a use case. So, another good one is scrap reduction. So again, when you're dealing with, carbon fibers, silicon, wafers, all the different things that our customers deal with, precious metals, hot metals, scrap is an issue. So we are working with a huge global hot metals company. If you're familiar with the micro mill, you're familiar with who these guys are. And ultimately, what we've built for them is we've taken a ton of historic data from their melt shop and from other parts of the business, and we've put that together to give their melt shop team tools to accurately predict and understand where they need to make where the ideal cut spot is for particular metal applications. And so these guys they do a ton of DoD work. They also do a ton of consumer product work. And again, they're doing it all in the same plant. So the level of variation across the product cycle is pretty wide. This helps them know exactly what to do with new products, current products, post-changeover products, et cetera. And we're looking at a 17% scrap reduction on a 1 million prime ton plant just here in the first quarter of working with them. So, again, another really cool thing about this stuff is that it gets smarter over time, right? So you may start with 15, 20, 25% reduction, but that reduction gets higher and higher the more data that the model has and the more context the model has. So again, just some examples here of how we're working with folks here in South Carolina and throughout the U.S. on helping them increase EBITDA by reducing things like poor quality and reducing scrap, right, and reducing unplanned downtime. So a little bit about us before we keep going and get into some more detail. We've been doing this for a while, since 2016, and our big focus really from day one was on manufacturing, high data, high security, high sensitivity customers. You see some of the names of the folks that we work with over there on the right. We've got two big innovations for our business. The number one innovation here is a technology integration innovation. And it's funny, we're actually up right now. Let me show you guys. We're a finalist for the Technology Innovation Integration Award here in the state of South Carolina. So we're pretty excited about that. But that particular innovation is all about knowing that our customer base is collecting data using a ton of different tools. We're not asking them to change any of that. What we are doing is we're saying, hey, maximize your value, minimize your total cost of ownership by bringing it all together here. Okay. The other big innovation that we have is a process innovation. The idea of making data available to other parts of the business that did not have availability and did not have visibility into that data before. So, for example, is your maintenance guy working with your quality guy? Is your quality guy working with your supply chain guy? Do they understand how each of their activities impact the other, and in turn impact overall profitability? So the ability to be able to really help people understand how different aspects of the business influence outcomes is another big kind of business process innovation that we bring to the table. We talked a little bit about the software. We'll get into that in a minute. When we think about our core value propositions, we consider ourselves an automation company, right? So when you think about automation, you think quick and you think cheap, right? We try to check those boxes. So we tend to get through this process a lot faster than doing it on your own or working with some of the bigger guys. We talked a little bit about how we try to do our best just to fit in, right? We want to integrate with what you have. We want to learn how your people work and give them the capability. We're not asking them to change their life. Security is a big part of our message, right? So one thing that people don't always know about Delta Bravo is that every single person that works here either has their top secret, DoD top secret clearance, or they're in the process of getting it. So that is a huge part of our culture and a huge part of the way we work. We talked a little bit about our relationship with the aerospace cluster before. This company is born and bred South Carolina. We're located right up in Rock Hill. We would not be alive. We would not be a successful, thriving business if it was not for the assistance from the state of South Carolina, particularly the SCRA, the SCMEP, the South Carolina Council on Competitiveness. These groups have been influential in our ability to grow from a cool idea that a couple of nerds like me and my buddy had to being what we are today. So we are very, very much integrated with the folks at the state. They can probably tell you more stories about our customer success than we can at this point. But again, I just want to give you guys some level of context of who we are and what that relationship is. So with that being said, let's kind of continue the discussion. And the first thing that I want to, as we kind of get into what makes this stuff work, what makes a successful machine learning and AI project. The very first thing that, we want to make sure that you guys understand is the importance of having a clean data set. All right. So what I'm going to do is I'm going to walk you guys through just a very short process that we've gone through with a heavy equipment company that's in the aerospace vertical they have to move a lot of big, huge, heavy parts from one location to another. And they said, guys, we want to minimize the amount of moves that we've got to make. We want to minimize the dwell time for these parts. We want to make sure that they're in the right place at the right time. And so what's interesting about this business is that they have grown through acquisition. And they have gone through a pretty serious process in the last couple of years to narrow it down to 2 systems, right? So you think a big company, you'd hope they'd be on 1 system, right? These guys are getting there. They started on 5, now they're down to 2. Hopefully they'll be on 1 in the next year or 2. And so we took data from 2 completely different ERP systems that had 57 columns and over 2,300,000 rows. So you have 132 million data points. That's where we started. Then we said, you know what? Let's clean that data down. Let's get rid of some duplicates. Let's go to some blank stuff. Let's go through our standard deviation process. And that took us down to 63 million data points. From there, we said, okay, let's take a look at the inventory locations. There are 78 of them, 28 invoicing locations, 58 website locations. Let's put all that stuff together. Let's identify what they have in common to reduce those attributes down to 22. Let's look at these status codes, 3,500 legacy status codes in this massive data set. Let's reduce that down to 20, then we had 22 active, right? We reduced all that down to 9. So what we're doing is something called feature engineering. This is the idea of identifying all the pieces of the data that have a degree of commonality, getting rid of the outliers, bringing those pieces that have a degree of commonality together, and understanding some level of perspective and context on that commonality. And so what we ended up with is we started with 132 million data points, ratcheted that down to 41 million usable, applicable, and relevant data points. And that is for their global data set. So from there, this is where things got interesting. So if we want to start modeling moves, modeling dwell time, out of those 41 million data points, how many do we really need? And so you see that we went through the same process to kind of start breaking that down to 227,000 relevant data points that were used in our model that actually helped them identify a lot of inefficiencies in how they're moving product. And so this is really the number one challenge that every customer has, is how do I go from a massive amount, an ocean of data, into a relevant, clean data set that is very specific to the problem that I want to solve, right? So that is the number one thing that everyone goes through, the number one challenge. And this is really kind of, what our technology is built to address. And so you'll see that, this is kind of a quick 1-2 on how everything works. So the first thing that we do is we start off with those external data sets. So we'll say, okay, is it coming from a machine? Is it coming from your CRM system? Any way you slice it, doesn't really matter to us. A data set is a data set. So what we do is we connect to that data set. And again, this is all within, kind of behind your firewall, within the security parameters of your organization. and we will connect, through VPN or within the network to those data sets. Our technology will connect to them, bring them in to what we call the data cleansing process. So the first bit of that is bringing it all into what we call a data lake. All right. This is where all the relevant data is in the same spot. It's unstructured, it's unorganized. And from there, we use our technology to clean, join, and transform that data into the kind of single source of truth curated data set that you would see in a data warehouse. So from there, once we've got all this stuff together, we understand how it works. It's all cleaned up and joined and ready to really perform a thorough analysis on. We've got an advanced analytics module that we use to visualize the data, model the data, and then ultimately move that out to a machine learning model and into an AI context. So that's really kind of how the process works, right? This is what you're going to have to go through, and this is what our technology is built to facilitate. So with that being said, let's get into some in-depth about what we've been doing with RollsRoyce. So this is a great case study. We've been working with them for about 1.5 years. This was a keynote presentation at the Smart Manufacturing AeroDef conference this year, as well as the South Carolina Manufacturing Automotive Council. So this has been kind of a pretty popular story for us to tell. We love it. So let's talk a little bit about what actually went on. So RollsRoyce Power Systems is based in Aiken, South Carolina. We were introduced to them through the SCRA and through the South Carolina Manufacturing Extension Partnership. And they produce some pretty big engines. You can take a look at that picture. That gives you a general idea. Those things are about the size of your SUV. And the applications for those engines range from fracking engines to yachts, locomotives, big, huge gen sets, construction applications. These are big, huge, powerful 10,000 horsepower engines, right? So, and when they put those engines together, there are some scenarios that impact EBITDA. So specifically, we wanted to focus on reducing the cost of poor quality. So when those engines get put together, so they go through a supply chain process where parts are procured, tested, and then when they go to the test cell, those parts are assembled onto the engine. And so if these engines fail at the point in the test cell, it's a very costly proposition, tens of millions of dollars per year for Rolls-Royce. And then if they get through that cycle and they make it out into the field, and there's a failure in the field, you can imagine, I mean, if you have a fracking engine that's running 24 hours a day in Australia, the whole idea of going out there, stopping that thing, sending people to fix it, investigate it, replace it, tremendously expensive, right? So the big question here from a business standpoint was, can we leverage the data that we're collecting today to predict these failures, to avoid them, to understand why they're occurring, and to reduce that overall failure rate, and also reduce the amount of warranty claims we have in the field. And then the last bit, big requirement here was, guys, our operators are pinned as it is. We cannot expect these guys to learn new things and incorporate new processes into their lives. So whatever capability you guys come up with, it's got to be something that fits into the way we work every single day. So this is really this sets the stage for the work that we did here. So what I'm going to show you guys is kind of just a quick insight into what our software actually looks like and kind of where we started. So we talked a little bit earlier about the importance of establishing that clean data set. And so this is really where we started. We started with data from 3 different sources, from the ERP system, from a SQL server that's used to measure a degree of quality and assembly data. And then we also have what's called iTest, which is their test cell software that they've been using for the last 10 years. So we got historical data from 5,000 engines. And we think about those 5,000 engines from a percentage basis, 95% of them were just fine. Only about 5% of them were, failed in that test cell process and cost the company a lot of money. And we think about how much data was brought in. More than 2 billion data points were ingested into our technology. And within 48 hours, we had that distilled down to 200 million relevant data points that we were going to use to solve the problem. So you can see that when you take a look at the graphics here, you can see that our technology is built to visually establish workflows. However, behind each one of those workflows is a good bit of intellectual property, a good bit of scripting, and a good bit of modeling that helps streamline and automate the process of moving from 2 billion data points to 200 million data points in less than 48 hours. Okay, so that's kind of what you're seeing on the back end. So from there, we say, okay, well, that sounds great. We have now taken data in from all these different sources that can help us really kind of, from a 360-degree perspective, really understand, the relevance and kind of what we're dealing with here from a problem perspective. What do we do with it? So the first thing that we do when we break all that data down into the relevant stuff that matters is we start to understand correlations in certain metric behavior against the outcome that we are trying to predict. So in this case, we are trying to predict a failed engine. And so what you guys are looking at here is called a correlation matrix. And so what we're able to do is say, based on this outcome of failure, and out of all these metrics that we are collecting, which of these metrics is most and least influential on the outcomes of failure? Which metrics have a positive correlation, meaning that as they go up, the likelihood of failure goes up? Which metrics have a negative correlation, meaning as they go up, the likelihood of failure goes down? All right. This is the first step of really understanding and putting together a successful predictive model. Okay. And so what you'll see here is that, all of these relationships, these correlations have been documented numerically. And if you look at these numbers, there's going to be one number that's missing. And that number that's missing is 0. Okay. So that is very important to understand that in the context of predicting an engine failure, there was a number of data points that had a 0 correlation. All right, meaning that they had nothing to do with this one way or the other. And that's that gray shadow that you see here. Those are the whole bunch of data points that we have deemed irrelevant to solving this problem. And this is important, right? You have to have the right stuff in there to be able to solve the problem. And this is that first step. So you'll see that there's a number of metrics over here, dyno related metrics, crankcase pressure related metrics, that as they rise, the likelihood of failure goes up. And this is really the first step in solving the problem. So the next step that we took in solving the problem was saying, okay, now that we understand what metrics are really influential on this outcome of failed engines, let's start to baseline these. Let's see how they act, and let's see if there's anything that's different in the failed engine in their behavior versus what's going on in an engine that ran just fine through the process. And what we found were some really interesting bits here. So you'll see that little gray shadow, that is our prediction band that we use to help us understand how those metrics should act in an ideal state. And what's interesting here is that we saw that for certain critical metrics that were absolutely influential on the outcome of failure, in the failed engines, we see these average anomaly scores of 0.24 versus 0.10 in the exact same metric in the engine that was successful. So what we're starting to do is we're putting together a picture of how certain metrics act in a fail scenario versus a success scenario. And we're seeing that in the fail scenario, certain metrics have an average anomaly score that's exponentially higher than they do in a success scenario. And this is kind of what helped us put together that model. And so what's interesting is we talk about the results. And again, I'd love to get into more details with this. If you guys have any interest and dive in even deeper, you can just reach out to us directly. We can kind of walk you through the process. But what was really awesome about this is that we were able to put together a model that would predict failures in that test cell more than 30 minutes before they were going to happen. And that model would tell and understand what was going to cause that failure and why. All right. And so what was interesting about this is another lesson learned kind of a testament here, is that we were, we thought we were Einstein for a minute here. We deployed our initial models to predict this in the first 45 days of the project. Okay, so we were in there and lickety split, had a model that we wanted to go through and use to solve this problem. And in the first 2 weeks that model ran, we predicted 2 engine failures. I mean, it was a huge success. Then all of a sudden, in week 3 and 4, we had 1 or 2 false positives. When you think about that for a second, think about the impact of a false positive in this situation, where you've got to take apart a multi-million-dollar engine that's taken a week to put together in the first place. So obviously the impact of a false positive was a huge deal. So we had to take a step back and say, okay, is this the right model? Is this combination of models the right approach? Are we missing a data point or two? And what we found is that that the data that we were collecting, we wanted to collect it in a more granular way to help us avoid those false positives. So we had the RollsRoyce folks go from collecting a half hertz data up to 10 hertz. And that made all the difference in the world. We made another slight model adjustment. And then all of a sudden, within a week or two after our couple of false positives, we had a model that was out there, cranking out predictions with 0 false positives. And that was a huge deal. So then we said, great, now that the model is proven out, how do we integrate it into their everyday lives? And this is an awesome story. So we talked a little bit about this software product called iTest that RollsRoyce uses in their test cells, right? They've been using this product for like 10 years, and their operators are slam dunk whizzes at iTest. So what we did is we said, okay, we're going to integrate with iTest. And via API, we connected from our platform to iTest. And when our model predicts a failure, it kicks a script out to iTest that pauses the test. And their operator gets a little pop-up in the iTest application that they've been using every day for the last 10 years. And that pop-up reads, test paused, anomalies detected in these metrics. Please replace this part and restart the test. Just that simple, right? And we give them some level of metric identification of what's happening, and boom, it's done. So they never even knew who Delta Bravo was for a little while. All they knew is that iTest all of a sudden was predicting problems and life got easier, right? And that's the way we want it, right? We want that level of integration. And so in the time since, we have extended those models to all the engines that they produce out of that plant. And not only are we predicting failures in the test cell, but we have gone and taken all the historic data from units that have already been released out to the field. And we are now able to create a probability of failure in those existing field engines for what's called low hours failure. The idea is there, if it's sub 1,000 hours, is this thing likely to fail or not and become a warranty claim? And so we've been able to help them get out there and proactively contact these customers that have engines that are susceptible to potential low hours failure, and make that a maintenance call and a friendly customer call as opposed to a warranty call. So when we think about the ROI on this project, we are well past the 10x ROI point at the moment. And what's interesting is that out of all the Rolls-Royce Industry 4.0 projects that they've engaged in worldwide, this one here, locally here in South Carolina with our little local South Carolina company, has got the greatest return on investment. And so some really cool stuff that we can do out there, guys. Again, if you've got the data, usually in aerospace, the reason why we love working with folks like you is that you're collecting this data whether you like it or not. It's part of the process and it's part of your compliance requirements. Real question here is, what are you doing with it? And what are you doing with it to increase EBITDA and reduce operational cost? So big lessons learned. Number one is that this is not the type of thing you want to do in a Don Quixote situation, right? So you want this to be something that's part of your culture, right? So, for example, we've had projects where you'd have one guy that's a process engineer that sees this, that believes in it, but he doesn't have any organizational pull beyond his immediate group. He can't get the finance guys in there to help quantify this. He can't get the maintenance guys in there to help get machine data. Ultimately, you have to make the experts available. You have to have the right people in the room in order for this to work. What we've found is that the right people in the room are typically process engineers, quality folks, finance folks, and maintenance folks. If you can bring them in, that is the group that you want that can give you the context that you need to be successful in the project. Another big one is one size does not fit all. So I can tell you guys right now that we've been brought into at least 5 companies that have spent $1 million, if not more, with software products that say, hey, we've got a pre-built model. We already know how to do this. Predictive maintenance is just part of what we do. It's built in. Fundamentally, that logic is flawed, right? Because how did they train those models? Were those models trained on your context using your data and your application? If they weren't, then how's that going to work? And how long is it going to take to get it to work, right? So that's just another big thing to realize as you go into this, that there's no silver bullet. There's no one size fits all. It has to be built in a way that's very specific to your processes. And then lastly, one thing that we can tell you is that not a single customer that we've worked with, not one out of over 60, okay, not a single one of them has had a pre-existing frame of reference for what these projects take, what they cost, how much they're going to cost to scale, what level of involvement their teams are going to have. And so what we've done is we've stepped back and said, you're right. At some level, even though that this is, we've done this a bunch of times, from your perspective, there is risk here. And so what we encourage our folks to do is bite-sized chunks. Hedge your risk, build your credibility incrementally. Do this in a way that's step-by-step, affordable, and illustrates returns. And that's really kind of, we talked about Rolls-Royce. Iteration is key. Pilot, proof, going back, iterate. Don't expect your provider, your partner, us, to have this perfectly nailed down in 2 weeks. We are going to have to talk. We're going to have to go through this. This is part of the process that builds credibility and that builds a successful result. And again, don't spend a ton of money. You don't have to. This stuff, these incremental steps can be done very, very affordably. And this is something that we do a lot of work with the SCMEP on. And so this is kind of, where I'm going to wrap up before we kind of open up and get some questions going. And that is, ultimately, there are programs, whether they're available through the aerospace cluster or through the MEP, that can help offset some of the financial cost of going down this road and understanding what's happening. And we are part of that group. And what we're able to do is we're able to offer this assessment that can potentially be offset by funds if they're available. Again, that's not my world. You can talk to Susie and Cynthia and all the other folks that control that. I don't. But ultimately, we work with those groups to help you understand where you can be in this process and what you can do with the data that you have today. We'll help you identify gaps and create a best practice approach to understanding, what it's going to take to get you from mountains of data to turning that into something that can actually contribute financial payback to your business. So I'm going to kind of wrap it from here. Number one, I want to confirm if everyone's still awake. So a lot of talk in there, a lot of action. I'd like just to kind of open it up. If you guys have any questions about, applications, best practices, fashion advice, we're all ears. Any questions? Open it up.
Thanks, Rick. I had a question. This is Steven. Do you do anything with like helping create visual displays so that people so in the test cell, I understand that you created, the pop-up that says, hey, go replace this, but what about like earlier on in the assembly process? Have you ever done anything like that for those operators so that they can catch it, in step 3 rather than a test?
Yeah, so you saw some of those interfaces from the predictive maintenance and predictive quality solutions that we've put together. So creating interfaces that map to an operator's process is a big thing that we kind of pride ourselves on. So, and you got to remember, there's certain steps in a process where people do not have the ability to change them. And so what we like to do is we like to work with the operators to understand where in the process they can affect change. And we'll put something together to give them that advanced warning and give them that suggestion that's very specific to the change, the time, kind of the change they need to make and when they need to make it. For sure. So, Don, do you have anything to add on that one?
I was going to suggest it has a lot to do, Stephen, with, we spent a lot of time talking about leading and lagging indicators. Rick said that a lot of this stuff is static. We try to work very closely on dynamic variables so that we have the ability to identify if something goes wrong. If something drifts out of tolerance or is drifting towards being out of tolerance in, say, step 7, we, through the machine learning capability, then know that, hey, danger, Will Robinson, this is a leading indicator for a problem that may not manifest itself until step 11, but we've got the opportunity to fix it at either step 2 or 3. So we don't need to wait until step 11 to take something offline or make a correction with a chemical process.
Sure.
That help?
Oh, yeah, absolutely. That's great.
Anyone else have any? Let's see if we, usually we can move over to the chat here, right? And we can see if anyone wrote anything in.
Rick, you asked about fashion. Can I comment on your shirt?
Oh, gosh. Can I stop you? Oh, no. Yeah, what can I say? This is a dad bod, dad fashion here. All right, so what else do we have? Anyone else have any feedback, thoughts, questions, concerns?
Rick, I think one important thing to also point out is we generally, after a first date, move very quickly to an NDA. We are working with the secret Coca-Cola recipe for many of our companies and customers. And so it's very, very important for us to, as quickly as possible, execute a mutual NDA.
Yeah, it's a big part of the process. And that that's another good one to share as a best practice, right? Is before you go into the process of looking through this and selecting your vendors, make sure that you get everybody on an NDA as quickly as you can. It's never a problem, right? It's never a problem to sign an NDA if you're serious about working with somebody. Trying to think if there was anything else. I'll say for this audience, I wish we could go into a little more detail about. We've been working with the F-35 team on tracking critical part movement, and so that'll be another one. Oh, there we go. Appreciate it, Ashley. Thank you for the positive words. But yeah, I think that unless you guys have anything out there that is specific, want to talk a little bit more about particular use cases or any other lessons learned or road bumps, anything like that, we're happy to do it. You see Don and my contact information right there on the screen. We love meeting new folks, especially down here. And if Nick said, having a conversation about what you can do is free. So we'd love to hear from you and love to learn more about what you guys are doing.
Stephen, Susie, Alex, Adrian, everyone, thank you very, very much for your time today.
Right.
Well, thank you guys.
Thank you all for doing this.
Yeah, we were just so thrilled that you guys were willing to put this on for us, and explain to you what you do, and so thank you for that. And I even texted Susie and Adrian in the middle of this and said, hey, I think this is going really well, because I used to work next to a team that did this sort of work, and they're explaining it in a very, very good manner. So I hope everybody else found it as interesting and easy to understand as I did. So thank you for that.
Yeah, we appreciate the translation.
Oh, awesome. All right, cool. All right, guys. Well, thanks again for the opportunity. I'll tell you what, we are thrilled and flattered to be your first presenter. Hopefully it only gets better from here.
Yes, absolutely.
Thank you,
All
everyone.
right, guys. Have a great day.
Thanks, guys.
All right. Thanks, everybody.